All right, let's dive into Rust. We've got some cool stuff to unpack today.
Yeah, should be fun.
You bet. We got two sources, actually.
Right.
One is a bunch of common Rust interview questions, and the other is all about, like, the origin story of the language.
A fascinating story.
Yeah. So this deep dive is for everyone, really.
Absolutely.
If you're prepping for a coding interview, awesome. But even if you're just, curious about Rust.
Feel curious.
Yeah, curious about why it's such a big deal.
Right.
You'll get a lot out of this.
Yeah.
We're going to cover how Rust manages to guarantee memory safety, but without
Yeah.
the performance hit you usually get with garbage collection.
It's pretty impressive how they pull that off.
It is. And we'll also dig into how this thing started as like a personal project at Mozilla.
Yeah. Just
If
someone
you got-
tinkering around in their spare time.
Crazy,
Yeah.
right? And now it's this game-changing language.
It's amazing how these things happen.
I know, right? So for anyone out there gearing up for a Rust interview,
Interview prep.
oh yeah, time to get serious.
Gotta be ready.
There are some core concepts you absolutely got to know.
Yeah, like you can't just wing it.
No way. It's like trying to climb a mountain without, I don't know, knowing how to use a rope or something.
Exactly. You need those foundational skills.
Right. So let's start with the big three.
The holy trinity of Rust.
Ownership, borrowing, and lifetimes.
Mm.
I remember when I was first learning Rust,
Oh, yeah.
these were the things that really tripped me up.
I hear you. They can be a bit of a mind bender at first.
Total mind bender.
Mm.
But they're also like the heart of what makes Rust so special.
Absolutely. They're what give Rust its power.
Right. So let's break them down one by one,
Okay, let's do it.
starting with ownership.
Ownership. It's all about control, really.
Okay, so walk me through it. I'm still a little fuzzy on like how it actually works.
All right, so imagine you're writing a letter, like an old school letter.
Okay, with pen and paper.
Exactly. You own that piece of paper, right? And everything you write on it.
It's all mine.
Right. Now, you can choose to give that letter away to someone else.
Like mail it to a friend.
Yeah, exactly. And once you do that, you no longer have any claim to it.
Makes sense.
That's ownership in Rust. Every piece of data, it has a single owner.
Oh.
And when that ownership is transferred, the previous owner, they can't access it anymore.
So that's how it prevents those like accidental deletions or changes.
You got it. It's a built-in safeguard.
Very cool. So borrowing?
Oh, borrowing. That's like lending that letter out for a bit.
Okay, so I can let someone else read it.
Yeah, but just like lending a book, there are rules, right? You can only lend it to one person at a time.
Right.
And they got to return it eventually.
Makes sense.
And in Rust, those rules, they're enforced by this thing called the borrow checker.
The borrow checker.
Yeah. It makes sure that references to data, they're always valid.
Oh, that's important.
It is. It's like having a super strict librarian,
Oh, I get it.
making sure no one's trying to read a book that's already checked out.
No double dipping on the data.
Exactly. So then we have lifetimes.
Ah, yes. Lifetimes. This one was always the trickiest for me.
Yeah. It can be a bit mind-bending at first.
Seriously mind-bending.
But think of it this way. When you lend out that letter, you might tell your friend, hey, you can borrow this until Friday.
Until Friday.
Right. Until Friday, that's like a lifetime annotation in Rust.
Oh.
It tells the compiler how long a reference to that data, how long it's guaranteed to be valid.
So it's like setting an expiration date for that borrowed data.
Exactly. And the compiler, it checks these lifetimes. It
Ah.
makes sure there are no potential memory errors.
So it's like a safety net.
Yeah, built right into the language.
That's amazing. And all of this happens without a garbage collector.
No garbage collection needed.
That's so cool. That's one of the things that makes Rust so attractive for, performance critical stuff.
Absolutely. Because garbage collection, it can cause those unpredictable pauses.
Right. And in some applications, that's just not acceptable.
You need things to run smoothly.
Smooth and fast. Okay, so we've got ownership, borrowing, and lifetimes. What other key topics might come up in a Rust interview?
Well, smart pointers. Those are a big one.
Smart pointers.
Yeah, you see, Rust gives you this amazing control over memory management, but sometimes you need a little more flexibility when you're sharing data.
Right.
That's where smart pointers come in.
Okay, but there are like a few different types, right? There's box,
Yeah.
RC, ARC.
Yeah.
What's the deal with all those?
Think of it like sharing a pizza.
Okay, I'm listening. Pizza and code, two of my favorite things.
Perfect. So a box is like ordering a whole pizza just for yourself.
The whole pie.
You have sole ownership, no sharing it.
Gotcha.
An RC, though, that's like sharing slices with friends, but you're keeping track of who's got what.
Oh, well,
So if someone drops their slice, no big deal. The pizza's still safe as long as someone's still holding on.
right.
No wasted pizza.
Excellent point. So RC is all about like shared ownership within a single thread.
You got it. Then we have ARC, which is like sharing that pizza, but across multiple tables.
Oh, wow. Multi-table pizza sharing.
Exactly. This is for sharing data between different threads.
So each thread gets its fair share.
Exactly. And everyone stays safe. No one gets food poisoning from someone else's slice.
That's a vivid analogy.
But you get the point. Choosing the right smart pointer, it's all about how you're using and sharing that data.
It's all about context.
Exactly. And interviewers, they'll want to see if you can apply this to, real world situations.
Right. Not just like regurgitate definitions.
Right. You got to be able to use
You
it.
got to show you can use it. Before we move on to the origin story of Rust,
Yeah, that's a good one.
is there anything else about interview prep that you'd want to highlight?
Oh, yeah. Definitely make sure you're comfortable discussing error handling.
Oh, error handling.
It's a big deal in Rust.
Okay, so how does Rust handle errors? Is it like a totally different approach?
It is, kind of. It uses this thing called the result type
Result type. Okay.
and this really cool operator, the question mark operator.
The question mark operator.
Ah.
What's that all about?
It's like it lets you handle errors really gracefully without resorting to exceptions.
Ah, so no more clunky try-catch blocks.
Exactly.
Much cleaner.
I like the sound of that.
Eh,
But there's more to it than just the question mark, right?
there is. You also want to know about like custom error types.
Oh, so you can create your own error types.
Yeah. And using crates like this error or anyhow for those more complicated situations.
So you can really tailor your error handling to your specific application.
Absolutely. And that's what interviewers are looking for, that deeper understanding.
Gotcha. So error handling in Rust, it's not just about fixing bugs, it's like a design philosophy.
Yeah, it's about building robust and maintainable code.
Right. Okay, we've covered some key areas for insing that Rust interview, but this deep dive isn't over yet.
There's more to come.
Oh yeah, we got to talk about the origin story of Rust, and
It's a good one.
it's fascinating. I mean, most programming languages.
They're born in like the labs of these giant tech companies, right?
Right, big teams, lots of resources.
But Rust, it started as a personal project, which is
Yeah, pretty unusual.
no, right?
And it all started with this developer named Graydon Hoare.
Okay, so we've talked about some of the stuff that makes Rust so unique, but also, maybe a little tough to learn at first.
It definitely has its quirks.
But to really like grasp its impact,
Mm-hmm.
I think it helps to understand where it came from.
Oh, absolutely. The origin story is fascinating.
It started as a personal project, right?
Yeah. Back in 2006, there was this developer named Graydon Hoare.
Okay.
He was working at Mozilla Research, just doing his thing.
Mhm.
And in his spare time, he started messing around with this new language.
So it wasn't like an official Mozilla project or anything?
Nope, just a side hustle, a passion project, really.
Wow. So what was his goal? Like, what was he trying to create?
He wanted to build a systems programming language, but one that was safer than C++.
Safer than C++.
But without sacrificing performance.
Okay, so that's a tall order.
It is, but Graydon, he had this vision and he just started tinkering.
It's amazing to think that Rust, this language that's used by like major companies now,
I know, right?
it started with one person just messing around in their free time.
It really shows you the power of like individual ingenuity.
And a little bit of luck, too, I bet.
Yeah, definitely.
Yeah.
Because as Graydon's project started to take shape,
Mhm.
Mozilla saw the potential and they decided to officially sponsor it in 2009.
Oh, wow. So they were like, hey, this thing you're working on, it could be huge.
Exactly. And the timing was perfect because Mozilla was working on this new browser engine called Servo,
Servo, right?
and they needed a language that could deliver both safety and performance.
Yeah, Rust was the answer to their prayers.
Pretty much. They saw Rust as the key to building a better, more secure web.
Okay, so from a personal project to a core part of a major web browser, that's
A pretty impressive journey.
an understatement.
Yeah.
So what happened next?
Well, the years that followed were full of milestones.
Give me the highlights.
In 2010, they publicly announced the project, which generated a ton of buzz.
Yeah, I bet people were probably like, what is this Rust thing?
Exactly. And then in 2012, the Rust compiler became self-hosted.
Self-hosted, meaning,
It was written in Rust itself.
oh, wow.
That was a huge step towards maturity.
It's like the language was growing up, becoming independent.
That's a great way to put it. And then, of course, there was the big one.
The 1.0 release.
Yes, Rust 1.0 in 2015.
That was a big deal.
It was. That marked Rust as stable, production-ready.
Ready for the big leagues.
Exactly. It was a celebration for the entire Rust community.
I bet. And it signaled to the world that Rust was here to stay. From a side project to a 1.0 release in, what, less than a decade?
It's pretty remarkable, right?
It is, but the story doesn't end there, right?
Nope. In 2021, the Rust Foundation was launched.
The Rust Foundation.
Yeah, it's an independent organization with support from some major players.
Like who?
Amazon Web Services, Google, Microsoft, Huawei.
Wow, so some serious backing.
Yeah, that shows you how much faith the industry has in Rust.
It's like they're all betting on its success.
They are. And it all goes back to those core principles that make Rust so compelling.
Okay, so remind me, what are those principles again? What were the driving forces behind Rust?
Well, safety was paramount right from the start.
Hmm.
The ownership system, the borrowing rules, no null pointers,
Right.
all designed to prevent memory-related errors.
So no more seg faults, no more crashes because of bad memory access.
Ideally, no. But safety wasn't the only goal.
What else?
Performance. Rust was built to be fast.
Okay.
One of its key principles is this thing called zero-cost abstraction.
Zero cost abstraction.
Which means that, like, high-level features, they compile down to really efficient machine code.
So you don't have to sacrifice performance for readability.
Exactly. You get the best of both worlds.
That's awesome. What about concurrency? How does Rust handle that?
Oh, concurrency is another area where Rust shines. It makes writing concurrent code much easier and safer than in, say, C or C++.
It does.
Its approach to ownership and borrowing, it extends to multi-threaded programming.
Oh, interesting. So you're less likely to run into those nasty concurrency bugs.
Yeah, things like data races, they become much harder to create.
So it's like built-in safety for the multi-core world we live
Yeah,
in.
exactly. But it's not just about the technical stuff. Rust was also designed to be practical.
Practical. Okay.
It has this fantastic package manager called Cargo.
Cargo, right? I've heard good things about it.
It's great. And the error messages, they're super helpful.
Not like those cryptic error messages you get in some other languages.
No, they actually guide you towards a solution.
That's so helpful. And the community, too, right? I've heard the Rust community is amazing.
Oh, the community is phenomenal. Very welcoming, very supportive, especially to newcomers.
That's so important. So it sounds like Rust has really brought together a lot of great ideas from different sources.
Mm-hmm. Absolutely. It's got influences from C++, ML, even this research language called Cyclone,
Cyclo.
which really inspired Rust's ownership and borrowing system.
Though it's not just borrowing ideas, it's like synthesizing them into something new and innovative.
Exactly. And that innovation is having a real impact on the industry.
Okay, tell me about that. How is Rust actually changing things?
Well, for a long time, people thought that if you wanted ultimate performance,
Yeah.
you had to accept the risks of using languages like C and C++.
Like the memory safety issues, the crashes, the vulnerability,
all that stuff, it was seen as just part of the deal.
the price of performance.
Right. But Rust came along and said, no, you can have both.
You can have your cake and eat it too.
Exactly. You can have performance and reliability without sacrificing safety.
That's a game changer.
It is. And you can see this impact in how many companies are adopting Rust.
So it's not just Mozilla using it for Servo anymore.
No, not at all. Amazon Web Services is using it for infrastructure.
Wow, so it's being used for some pretty serious stuff.
Yeah. Microsoft is incorporating it into Windows components.
No way. Rust in Windows.
Yep. And Google's using it for parts of Android.
So from web browsers to cloud infrastructure to operating systems.
Rust is everywhere.
It's like it's quietly taking over the world.
Maybe. And it's not just the big companies.
Okay, who else is using it?
Smaller teams, startups, they're all using Rust to build robust and scalable applications.
So it's accessible to everyone, not just the tech giants.
Exactly. But it's important to be realistic.
Okay,
No language is perfect.
right. There are always trade-offs.
Exactly. One of the common criticisms of Rust is that it has a steep learning curve.
Yeah, I can definitely see that.
Those ownership and borrowing rules, they can be tough to wrap your head around at first.
They definitely can.
But once you get them, they become second nature.
And the payoff is huge, right?
It is. You get this confidence in your code's correctness.
That's a good feeling.
It is. Okay, another thing is the compiler.
Oh yeah, the Rust compiler.
It's super helpful, catches a lot of errors, but it can also be pretty strict.
Strict in what way?
It's very picky about how you write your code.
So sometimes it feels like you're fighting with the compiler just to get your code to work.
It can feel that way, but that strictness, it forces you to write better code.
So it's like a tough teacher, but ultimately it makes you a better programmer.
Exactly. And finally, the ecosystem.
The Rust ecosystem.
It's growing fast, but it's still relatively young.
Compared to like Python or JavaScript.
Yeah, those languages have been around for much longer.
So there might not be a ready-made library for everything you need.
That's right. You might have to build some things yourself.
So you might need to get your hands dirty.
A little bit. But hey, that can be part of the fun.
Yeah, sometimes it's good to figure things out for yourself.
It is. And the trade-off is that you get this language that's designed for safety, performance, and reliability.
And those are some pretty big advantages.
They are. And let's not forget the amazing community.
Oh yeah, the Rust community is awesome.
They're so welcoming, so helpful.
It really makes a difference when you're learning a new language.
It does.
Okay, so we've covered a lot of ground here.
We have, from the humble beginnings to the industry impact.
The challenges, the rewards.
It's been quite a journey.
It has. But there's one big question we haven't tackled yet.
And what's that?
The future. Where's Rust going? What's next?
Ah, the big question. Well, the cool thing about Rust is it's not just staying in its lane.
What do you mean?
Like, it's not content with just being a systems programming language.
Oh, I'm interested.
It's starting to branch out, making its way into other areas like web development.
Wait, web development? I thought that was like JavaScript's territory.
JavaScript's definitely king on the front end, yeah, the part that users see.
Right.
But on the back end, things are changing.
The back end, meaning?
The server-side stuff, the
Yeah.
logic behind web applications, APIs, all that.
So Rust is handling the data processing, the heavy lifting that happens behind the scenes.
Exactly. And there are a couple of reasons for this.
Okay, like what?
Well, first off, Rust is fast, really fast.
And speed is crucial for web services, right?
Absolutely. They need to handle tons of users, tons of requests.
If a website's slow, people just give up.
They bounce. So performance is key.
Gotcha. What else?
Security, web services, they're exposed to the public internet, which makes them targets for attacks.
Right. There are always people trying to find vulnerabilities.
Always. But Rust, with its memory safety and its strong type system, it helps prevent those vulnerabilities.
So it's making the web a safer place.
That's the goal.
Okay, so web development, I kind of get that.
Mm-hmm.
But you mentioned machine learning earlier, and that seems like a much bigger leap.
I know, right?
Like, how does Rust even fit into that world?
Well, think of it this way. Rust is really good at building the infrastructure, the tools that support machine learning.
Okay, so not necessarily the algorithms themselves, but like the foundation.
Exactly. Things like data processing pipelines, numerical computation libraries, even low-level interfaces for specialized hardware.
So the stuff that makes everything else work smoothly.
Yeah, and Rust's strengths, they really come in handy here.
Like how?
Its performance is crucial for handling massive data sets. And its safety features, they ensure that these critical systems, they stay stable, they stay reliable.
You don't want your machine learning system crashing in the middle of a training run.
Definitely not. Plus, there are already projects out there, like the TensorFlow Rust bindings,
Oh, interesting.
that let developers use powerful machine learning libraries directly from Rust code.
So you can leverage existing tools, but with the added benefits of Rust.
Exactly. It's opening up some really exciting possibilities.
It sounds like Rust is kind of like infiltrating all these different areas of software development.
Yeah, it's finding its way into some unexpected places.
Like the language that keeps on giving?
Maybe. But let's not get carried away. Every language has its strengths and weaknesses.
Right. No silver bullets.
Exactly. Rust is versatile, but it's not the perfect solution for every problem.
Okay, so what are some of the things to keep in mind? Like, when is Rust maybe not the best choice?
Well, as we talked about before, the learning curve can be steep,
It can.
especially if you're coming from a language like, say, Python.
Very different paradigms.
And the compiler, it can be pretty demanding.
Yeah, that strictness, it can be a double-edged sword.
It helps you write better code,
Yeah.
but it can also be frustrating at times.
Like a really tough but fair teacher.
Exactly. And then there's the ecosystem. It's growing, but it's still relatively young.
Right.
So you might not find a library for absolutely everything you need.
So sometimes you got to roll up your sleeves and build things from scratch.
Sometimes you do. But that's also part of what makes Rust so exciting.
It's like being a pioneer, exploring new territory.
Exactly. You get to be part of something that's evolving, that's growing.
Okay, so maybe Rust isn't for everyone.
Right.
But for those who are willing to put in the effort,
Mm-hmm.
it seems like an incredibly powerful tool.
It is. For building robust, high-performance software, it's hard to beat.
So to wrap things up, what's the one key takeaway you'd like our listeners to remember?
I think it's this. Rust is more than just a programming language. It's like a different way of thinking about software.
How so?
It's about putting Safety, performance, and reliability first without compromise.
Okay.
And sure, it has its challenges, but the rewards are significant.
It's about building a better future for software.
Exactly.
Well said. And it's amazing to think that this all started with one person's passion project.
It really is, from a side project to a language that's changing the world.
It's an inspiring story, for sure.
It is.
Well, on that note, I think we'll wrap up this deep dive into REST.
It's been a blast.
It has. A huge thanks to you for joining us and for sharing your curiosity about this incredible language.
My pleasure.
We encourage everyone to check out the source material, learn more about Rust, and maybe even give it a try.
It's worth it.
Absolutely. Until next time, keep coding, keep exploring, and keep that Rust compiler happy.
Happy compiling.